Hello everyone, this is educational material prepared on engine fundamental, which is the seventh part of the educational material, and it focuses on theoretical and actual valve timing. The learning objective. After this presentation, the student shall be able to explain actual and theoretical valve timing and also discuss different firing orders. Theoretical and actual valve timing. What's valve timing? Valve timing refers to when the valve is open and close in relation to piston position. The specifications are given as degree for timing point before or after TDC or PDC. TDC and PDC are the terms used to represent the position of a piston. When the piston is at the top, we said that is at the top dead center, and the piston is at the bottom, then we said it is bottom dead center. So the two centers represent the position of the piston. The Society of Automotive Engineers recommended practice is to measure the timing point at 0.006 inch or 0.15 millimeter valve lift. With mechanical lifter, the valve must first be adjusted to the specified clearance. Let's discuss about the theoretical valve timing diagram. The theoretical valve timing diagram is shown on this picture. So the inlet valve open at the top dead center, and the inlet valve close at the bottom dead center. So the inlet valve open and close only in the suction stroke or intake stroke. The fuel injection starts at TDC after the compression. So at this point, fuel is injected or ignition system release a spark. And this process continue after some degree after TDC. And exhaust valve open at bottom dead center, and exhaust valve close at the top dead center. So the four stroke of the four-stroke combustion engine are shown here. So the case of the theoretical valve timing diagram, all valves open and close in their assigned process. For example, the intake valve only open and close in the induction process, and the exhaust valve only open and close in the exhaust process. So there is no technique or no way to improve the efficiency of the engine. Normally, the theoretical valve timing diagram is not applicable. It should be adjusted. So let's see the actual valve timing diagram. So the actual valve timing diagram is applied on combustion engine. So for this specific engine, let's discuss all the cases. So in the actual valve timing diagram of the four-stroke diesel engine, the inlet valve open 25 degree before TDC, and the inlet valve close 25 degree after PTC. But in the case of the actual one, the intake valve open at TDC and the intake valve close at PTC. But now the intake valve open in the exhaust process and close also in the compression process. So there are additional or more opening angles for intake valve. And the fuel injection, when we see the fuel injection start 5 degree before TDC in the compression stroke, and the fuel injection continue after 25 degree after TDC. The fuel injection continue, so it's close after 25 degree after TDC, and exhaust valve open the exhaust valve open early, which means 50 degree before PTC, and the exhaust valve close after 15 degree, so 15 degree after TTC. So this is how the actual valve timing work. So there is a big difference between the theoretical valve timing and the actual valve timing. The exhaust valve starts to open at 50 degrees before PDC on the power stroke. The valve stay open until 15 degrees after TDC on the intake stroke. This gives more time for the exhaust gas to leave the cylinder. By the time the piston reach 50 degree before BDC on the power stroke, the combustion pressure has dropped considerably. Little power is lost by giving the exhaust gas this extra time to exit. The intake valve starts to open 25 degree before TDC. It remains open for 25 degrees past PDC after the intake stroke end. This gives additional time for air-fuel mixture to flow into the cylinder. So the volumetric efficiency of the cylinder will be increased. The exhaust valve close 15 degree after the intake valve open. This is a valve overlap of 40 degree. What's valve overlap? Valve overlap is the number of degree of crankshaft rotation during which both the intake and exhaust valve are open. Valves don't open and close instantly. It takes several degrees of crankshaft rotation for the valve to fully open and close after passing the timing point. Valve overlap help scavenge or expel the remaining exhaust gas from the cylinder. This is the valve overlap angle, 20 degree plus 20 degree. So the two valves are open at the same time for 40 degree. So valve overlap is 40 degree for this specific engine. Valve timing is a function of cam lobe shape and the relationship between valve opening and closing and the position of the crankshaft. This is the cam lobe. So in the cam lobe, there is a base circle, and this is usually the diameter of the camshaft. And there is a lift or a lobe. So this lift determine the amount of the valve travel. Let's see the different terms. So this camshaft is rotated in the clockwise direction. So the first part of the cam lobe is the ramp at the right side. So we call this part opening ramp. Then the next part which touch the valve is the flank. So we call it opening flank. Then the nose will touch the valve. When the nose push the valve, so the valve completely open. Then closing flank and closing ramp together complete the closing of the valve. So let's see the two different situations. The camshaft is overhead and the valve are located below. And here the camshaft is located inside of the block. Here the camshaft is located on the cylinder. So in this picture, the valve is in closed position. And in this picture, you can see the valve is in open position. So when the valve is open means the substance can flow through this free port. Here, there is no way to flow for the substance. In the pushrod type of design, the valve which is closed is shown like this. So the valve is closed. There is no contact between the rocker arm and the valve stem. But in this case, the valve is open. So the cam lobe push the tappet, and the tappet push the pushrod. The pushrod push the rocker arm. So the rocker arm pushes the valve downward. So the valve move from a plus and the port is open. Changing the relationship between the driving and driven gear or sprocket change valve timing. For example, suppose a worn timing belt or chain jumps time. This causes the camshaft to fall behind. The valves open and close later. This reduces engine performance and causes engine overheating. Timing gear and sprocket are marked so they can be properly aligned on reassembly. In this picture, you can see the timing mechanism and the timing gear, how the camshaft are connected with the crankshaft. So the camshaft and the crankshaft can be connected by using belt or chain. So here it is a chain drive type of valve gear mechanism, and in this picture it is a belt type of valve gear mechanism. So when there is a worn in the timing belt or chain, then jump of a time will be occur. So when a jump of a time will be occur, it cause the timing to fall behind. So the valve opening and closing period will be affected. Thank you for watching this video. If you are interested, please share with your colleague. Thank you.